We're given age of x, which is g of f of x, and they're asking us to find h prime of 1. I'm going to stop sharing for a second. So in order to find h prime of 1, what do I have to find first?
H prime.
Very good. Can anyone tell us what to write for h prime?
Isn't it a function 1 prime
G
times
prime of f of x times, very good,
f of x
times the inner function.
Inner function. So f of x.
F prime.
Prime.
Prime of x, yeah.
Good, awesome. So now I have the function, so then h prime of 1 will be g prime of f of 1 times f prime of 1. So let's start by finding f prime of 1. So let's look at the table. How much is f prime of 1?
4.
Excellent. Let me stop for a second. Now I have to find f of 1. So let's find f of 1. Can anyone give us f of 1?
3.
Very good. So for now, I'm going to stop sharing for a second. So for now, I know that I have to find g prime of 3. And then the answer gets multiplied by 4. So g prime of 3 now. G prime of 3.
9.
G prime of 3 is 9. Very good. Times 4 is 36. And that's our answer. Very good. Any questions? Any questions? Can I move on? Do you think we should still stay on this, in this section? Do you want to work on something else, or can I move on? These are calculator problems here that you see by graphing. We will graph a lot in chapter 4, a lot. Do we want to look at the equation of the tangent and any of these?
Can we do 58?
58. Let's look at 58. Very good pick. Okay, let me copy it. Y equals the square root of 1 plus x cubed and 2 comma 3. Perfect. So they want the equation of the tangent line to the graph at such and such. Perfect. So I know that it's y minus y1 equals the slope times x minus x1, where x1 is 2 and y1 is 3. But I have to determine this. How do I determine the slope?
You have to get the derivative.
Very good. Y prime. And we have a very important rule for the square root. So the square root of a function prime, we know, is 1 over 2, the square root of the function times the function prime. So this is carved in stone. Can anyone help us with this? Anyone?
One over 2 root 1 plus 3x times.
And we are not differentiating in the denominator. In the denominator, we're just copying it. Times
3x squared.
That's it. Awesome. All I have to do now is plug in x when x is 2. 3 times 4, 12 over 2. And we know the square root of this, 8 plus 1, is 9. The square root of 9 is 3. 12 divided by 6 is 2. So then the slope is 2. So then y minus 3 equals 2x minus 2, and I distribute 2x minus 4, but plus 3. So I have 2x minus 1. So we determined the equation of the tangent line to the graph of this function at this particular point. So if the graph is something like this, let's say this, at that point, which is here, right? The equation of the tangent line, this equation is y equals 2x minus 1. At this point, we will find a different equation because the tangent is different, the slope is different, the point is different. Good. Good point. Thank you. Okay. The next step, which page am I on? I think I'm on 9. Yes, I'm on 9. So 3.5, something called implicit differentiation. Implicit? What does that mean, implicit? Well, if I'm given y equals 3x squared, I'm given the function directly. Not implicitly, it's not roundabout. I'm given the function directly. Can I find its derivative? Yes, 6x. But implicit means I don't really have the function. For example, y squared plus 3y minus 4 equals sine y. Anyone would like to solve for y? No, because no one can solve for y. None. So this is the function, but this is the equation, and no one can solve for y. So in this case, we are still asked to find an expression for y prime. However, we are not going to use this notation. It's not wrong. We are not going to use it. We are going to use this notation, dy over dx. Can you use this? Yes. Will you get full credit? Yes. But don't, please. You'll see why. So we're asked to find an expression for the derivative of y, but we don't have y. So what can we do to find an expression for this? We're going to differentiate implicitly. So find an expression for the derivative of y using implicit differentiation. Why? Because I don't have the function. It's not given to me directly, so I can find y prime. Not a big deal at all. Do you remember when we solve an equation like x plus 1 equals 2? What do? How can we solve such an equation? Yes. So we are applying a procedure or an operator, like we'd like to say, to both sides. Okay, fine. I'm going to apply the same procedure to both sides, like I apply it here. I apply the same procedure, the same operator to both sides. I'm going to apply the same operator to both sides of this equation in order to find an expression for a derivative of a function that I don't even have. You can say, yeah, but you're still going to have y in that expression. True. But I found an expression for the rate of change of that y that I don't even have. Okay. Careful now, because when I am told to find dy over dx, this means that this is a function. And it has to be treated as one. So here I have a product of two functions, function 1, function 2, and the chain rule with the power rule in it. Here I'm differentiating 3 times a function that I don't have, so I have to use the symbol. This is nice and easy because the constant prime is 0. Here I have an outer function and an inner function. So the product rule on the first one. The first function prime, luckily, is 1, times the second one, plus the first function times the second function prime. We just looked at the chain rule. A function squared prime is 2 times the function to 2 minus 1 times the inner function prime, plus 3 times the function prime minus 0 equals outer function, inner function. When I differentiate the outer, I get cosine of y times, when I differentiate the inner, I get dy over dx. Let's take a moment and tell me if you want me to repeat any of the steps. Do we understand each step? It's okay if you say, oh, we don't. We'll have other examples as well, but is the procedure clear? It's very quiet tonight. So let me do this one more time just because no one says anything, so I don't know if to continue or not. First function prime is 1 times the second function plus the first function times the second function prime, 2y dy over dx, plus 3 times the function prime, negative 4 prime is 0, equals outer function prime is cosine y times inner function prime dy over dx. So notice that this is what we are after. This is our variable. At this moment, it's just algebra. I need these 3 terms to be on one side, and the only term that does not have the variable, I need this to be on the other side. So then, what do I have on the left? On the left, I have 2xy plus 3. I move cosine times this to the other side. I put everything in parentheses because I will factor out the unknown. 2xy times dy is this term. 3 times dy over dx is this term. Negative cosine times dy over dx is this term that is moved to the left. This term is moved to the right. And now I can solve for dy over dx. Can anyone give us the answer for dy over dx? Final answer.
Negative y squared over 2xy plus 3 minus
Excellent.
cosine.
This quantity, thank you. Excellent. This quantity over this quantity. And again, you can say, what did you accomplish? Nothing. Oh, I accomplished a lot. Although I don't have the function, I have an expression for its derivative. If you give me a point, let's say a comma b, that why I'm giving a comma b, because I have to be careful. I have to give you an answer. I have to find a point that verifies the equation. So if I say y equals 0, let's see what I get. Then I get -4. No, I don't get anything. So 0 doesn't work because I need x. So 0 will not work. I need to find another point. I have to find a point if I want to determine the exact rate of change. So yeah, it will take me a while to find a point. That's why I said a comma b, so I don't have to worry about it, because there has to be a point that verifies the equation. But so when x is 0, when y is 0, I don't have x. So that's why I said a comma b. Then I can evaluate it for x equals a and y equals b. We're going to choose an example from the book, which is already verified. I just made this one up on the spot. So if you tell me a point that verifies the equation, then I can tell you this answer, exact. So I have b squared at the top. I have 2ab in the denominator, 2ab plus 3 minus cosine b. And I'll give you an exact number, as long as this is a legitimate point on the equation. So although this expression depends on y that I don't have, I can still determine the exact if I have a point. And that's what we call implicit differentiation.